Hi, 6th graders. This video is on greatest common factor, so label your notebook accordingly of where you're going to take notes. And our learning target is being able to find the greatest common factor of 2 or more numbers. So before we talk about greatest common factor, we just want to remember what the word factor means. So if we look here, remember 2 and 3 are factors of 6 because 2 times 3 equals 6. Let's look down at this example right here. And we can see that there's Venn diagrams, there's a Venn diagram showing this example. So if we look at 12 and 18, and it just has some of its factors listed. So which factors are in the overlapping section? So this green is in the overlapping. 2 and 3 are both in there, meaning that 2 and 3 are both factors of 12 and 18. So is the product of 2 and 3 also a factor of 12 and 18? Well, 2 times 3 equals 6, and 6 is a factor of 12, 6 is a factor of 18, so yes, it is. So if we were to list out all of our factors of 12 and all of our factors of 18, we could find the ones that they have in common, and then the greatest, like the highest one, would be our greatest common factor. So here's some examples that you do not need to write down right yet because we're going to use these examples to solve other ones. But if we're finding the greatest common factor of 16 and 20, there are 3 different ways that we can find it. We can use method 1, list out all the factors. So notice right here, I've listed out the factors of 16 and I've listed out the factors of 20. I've circled all of the ones that they have in common. 4 is the greatest, so 4 is the GCF, or greatest common factor. Another method is using prime factorization. So notice that I've used a factor tree on 16 and 20. I got my prime factorization. I listed it out, both the prime factorizations right here. I found the numbers that are like the prime factors that they both have in common, and I can see they both have a 2 and they both have another 2. So I multiply those together and I get 4. And then we have the cake method, which is one of my favorite methods. Notice that I start with 16 and 20. I think of a prime number that they can both be, or not a prime number, sorry, just any number that 16 and 20 can both be divided by. So they could both be divided by 2. So I put a 2 here, and then I actually divided. So 16 divided by 2, this is how I got my 8, and this is how I got my 10. Then I asked myself, okay, what's a number that 8 and 10 can be divided by, which is 2 again. So then 8 divided by 2 is 4, 10 divided by 2 is 5, and now I ask myself, what number can 4 and 5 both be divided by? And the only one they have in common is 1, so that means I'm done. So then I take these numbers, I multiply them together, and I get 4. So let's practice all of these methods. We are going to find the greatest common factor of 18 and 48, and I would like you to write down the example with each method that I do. So we're going to start with listing the factors. We have 18, which is 1 and 18, 2 and 9, 3 and 6. Then let's go to 48. 1 and 48, 2 and 24. I'm going to run out of room. 3, extra comma there. 3 and 16. Now I'm going to go down here. 4 and 12. 5 is not a factor. 6 and 8. 7 is not a factor. And now I know I'm done because I'm back at 8, kind of on like the other side. So now I'm going to look and see what factors do they each have in common. They each have a 1. They each have a 2. They each have a 3. They don't each have a Oh, they each have a 6. So the 4 is out. They don't each have an 8. They don't each have a 16, 24, 12, 9, or 18. So it looks like my GCF is 6. Okay, let's do it with the prime factorization. So I'm going to take 18 and 48, and I'm going to factor it out with the primes. So 2 and 9, and then 3 and 3, these are all prime. So 2 times 3 times 3, and then I have, let's do 6 and 8, 2 and 3, and then we have 2 and 4, that's prime, and then 2 and 2. So with a different color, I'm going to write it down here. 2 times 2 times 2 times 2 times 3. So I look and I see they each have a 2 and they each have a 3. They don't have anything else in common. So I take 2 times 3, just one of each of them, 2 times 3, and I get 6. So my GCF is 6. And now let's do the cake method. So we have 18 and 48. I think of a number that they can both be divided by. So they can both be divided by, let's just do 2. So 18 divided by 2 is 9, and 48 divided by 2 is 24. I know they can both be divided by 3. So 9 divided by 3 is 3. 24 divided by 3 is 8. There's no other number that 3 and 8 can be divided by. So then I take my 2 and my 3. 2 times 3, and we get the GCF is 6. All right, I want you to try to find the GCF of each pair of these numbers. So if you want to use the same method on all 3 of them, the one that you like best, or if you want to try to use a different method on each one, awesome. Or maybe there's one method that you just don't understand or don't get, then don't try that one and try the other 2. Whatever you want to do, and then unpause and check your work. All right, so you check your answers and make sure that yours match up with mine. If not, go back and check your work and maybe you made a mistake. Whatever method you used for each one, we should have the same greatest common factor. So if you look at this one, 8 and 10, I decided to list out the factors. I can see that 8, the factors are 1, 2, 4, and 8, and for 10, the factors are 1, 2, 5, and 10. 2 is the greatest one that they have in common, so the greatest common factor is 2. For this one, for 6 and 12, I decided to use the cake method. For 6 and 12, they can both be divided by 2. Therefore, I have 3 and 6. Notice that 3 and 6 can both be divided by 3, so I end with a 1 here, and that's okay. And then 1 and 2 can't be divided by anything else, so I end up with this. 2 times 3, so GCF is 6. So sometimes, if one of the numbers is a factor of the other number, then sometimes the GCF is one of the numbers of the pairs, and that's okay. And then lastly, we have 10 and 17. Our GCF is just 1 because they have no common factors. So 10, the factors are 2 and 5, and then 17 is prime. So we know that the factors of 17 are 1 and 17. And so because there's nothing here that they have in common, then the GCF is just 1. When we find the GCF of 3 numbers, we do the exact same thing, except we just do it for the 3 instead of the 2. The cake method, I have to say, there is sometimes with 3 numbers that the cake method does not work. So I usually say just use the cake method for 2 numbers. There are a bunch of groups of 3 numbers that it works for, but I'm going to say for 3 numbers, make sure you use the factoring out or the prime factorization. So I did the prime factorization just to speed up this video just a little bit. And we can see that 12, the prime factorization is 2 times 2 times 3. 34, the prime factorization is 2 times 17. And then 60, the prime factorization is 2 times 2 times 3 times 5. So I'm going to write it. And notice that I'm writing it not with exponents, so that way I can see easily what matches up, what they have in common. And so notice that I'm just writing it all out. So I can see they each, so now I'm comparing all three. So I can see they each have a 2. The other 2 have a 2 and a 3 in common, but not this one. So therefore, the only thing that they have in common is 1, 2. And I just pull that out. I don't multiply them together. I only multiply it together whatever if I pull out another number. So the GCF of all 3 of these numbers is going to be 2. Okay, now you try to find the GCF of this set of 3 numbers. So pause the video and then come back and check your work. Okay, so this time I decided to list out all the factors of each number. So I factored out 30. And you can see here I have all the factors of 30. Remember, when we factor, we always do the pairs. So 1 times 30, 2 times 15, 3 times 10, and so forth. And then I have the factors of 45. And I like to do it in order from least to greatest as well. And then 75. So we have 1 in common, 3 in common, 5 in common, 15 in common, and then that looks like that is it in common. So the GCF of these 3 numbers is 15. And whenever I find the GCF of a number, I always want to make sure that it really truly is a factor of each number. So if I check for 30, yep, 15 times 2 is 30, 15 times 3 is 45, 15 times 5 is 75, just to make sure that we did not make a mistake and that it makes sense that it's a GCF because it's a factor of each one. The Irish cheerleaders are making spirit ribbons for upcoming Spirit Week. Blue ribbon comes in 24-inch spool, green ribbon comes in 30-inch spool, and gold ribbon comes in a 36-inch spool. They want to cut strips of equal length and use the entire spool of each ribbon. What is the length of the longest piece of ribbon that can be cut from each spool? So they might have a different amount of each color, but they want to make sure that each ribbon is cut to the same length. So basically what they need to find is the GCF of 24, 30, and 36. So 24, 30, 36. If you want to go ahead and find the GCF and then come back and check your work, that'd be awesome, or you can follow along with me in your notebook. So let's list out the factors of each one. 24 is 1 and 24. 2 and 12, remember the factors are what multiplied by what to get that number, so 3 and 8, and then 4 and 6. 30 is 1 and 30, 2 times 15, 3 times 10, and then 5 times 6. 36 is 1 times 36, 2 times 18, 3 times 12, and then 6, because 6 times 6 is 36, but we just put that in there once. So now let's look through and see what is the greatest one they have in common. They each have a 1, they each have a 2, they each have a 3, they each have a 6, and then it looks like that's about all they have left in common. So the GCF is going to be 6, or we would say 6 inches. So that means that each ribbon is going to be cut into 6-inch pieces. That's what the GCF is saying for this situation here. So the next question is, how many spirit ribbons can be made if the ribbons are cut into 6-inch pieces? So how many for each spool? So we know that we have, for blue, it's 24 inches. So we're going to take 24, divide it by 6, and we'll get 4 ribbons from the blue spool. Green is 30, so we do 30 divided by 6, which is 5, and we get 5 greens. And then gold is 36 divided by 6, and we get 6 ribbons from the gold. And then we need to add those together. I know that 4 plus 5 is 9, plus 6 is 15, so we're going to get 15 ribbon pieces total. And that's all I have for you for this video. Sorry for the length of this video. There's a lot of information that goes along with your greatest common factor, and the examples get a little bit lengthy. Make sure you have your notes the next time you are in math class. Thanks for watching. Go back and watch any parts of the video that you feel like you need to. Have a great day.